Number 23, we're given this linear function. B is a constant. We're told that g of c plus 7 is c over 4. What represents the value of b? Lots of constants flying around here, b's and c's, and we've got our x as well, our unknown variable. So this is all about function notation and following the golden rule. So if we have g of x is equal to b minus 15x, let's ignore this for a minute. Let's just look at g of c plus 7. How do I deal with g of c plus 7? Well, the golden rule states whatever I replace the x with inside the parentheses on the left, I make the exact same replacement on the right. So wherever I see an x on the right, I'm just going to pop in that c plus 7. And now we can bring this in. That we know that this thing, g of c plus 7, which equals this thing, also equals c over 4. Right, this whole the function value, the output of this function when we input c plus 7 is c over 4. And so this crazy looking expression should equal c over 4. And now we have an equation, which I'll write over here, in terms of b and c, that I can now solve for b in order to see what it equals, right? To see what it equals in terms of c. So I just have to clean this up. So b minus 15c minus 105. Yep, minus 105 is equal to c over 4. Let's get rid of this awful denominator. I don't want to deal with it. Let's just multiply both sides through by 4. So 4b, don't forget to distribute here. 4b minus 60c minus 420 equals c. Now we'll bring everything over. So we'll bring the 60c over to the other side and the 420 over to the other side. So I get 4b is equal to 61c plus 420. Where b is equal to 61c plus 420 divided by 4. Now, I don't see that as a choice exactly. I mean, I guess it's close to c, but I would like to verify that c matches. So let's essentially divide that 4 into these two terms. Just split this apart. So this is going to be 61c over 4 plus, now 420 divided by 4, we found that before when we did 105 times 4. We know it's 105. So indeed, this matches choice C. Another way to do this, if you don't want to deal with all these letters flying around, is pick a value for C, evaluate the functions accordingly, and see what choice matches to what B should be. So for example, let's pick a value for C. Let's make C equal to, kind of pick an easy number here, 4, just kind of looking ahead and seeing that 4 over 4 is 1. So let's actually go ahead and copy paste this problem down here so we have a clean slate. So if C is 4, then G of 11 would equal 4 over 4, or G of 11 would equal 1 when we plug in that value. So G of x is equal to B minus 15x. So G of 11 would be B minus 15 times 11, and this should equal 1. And notice this actually follows very closely to what we did before. We still have to evaluate the function at that value of 11. We still plug 11 in for x. We set the all equal to 1. I mean, we're doing the exact same thing. It's just instead of using c plus 7 and c over 4, we're using 11 and 1. So maybe you find that a little bit easier, not having to deal with the letters. You can just work with numbers. So b minus 165 is equal to 1. And so therefore, b is equal to 166. And now I just got to go to the choices and see which of these equals 166. So for example, choice A, if I plug in c is 4, I'll get 15. That doesn't work. For B, c is 4, I get 26. That doesn't work. For C, I'll get 61 plus 105, which is 166. Cool. And then for D, I get something that is 165. It's actually pretty close, but it's not quite there. I'm sorry, it's, 165. So not quite. We need it to be 166, so that's choice C. Now, if you wanted to use Desmos and a custom regression to do this, it's basically the same thing we just did with plugging in. You're just letting Desmos do the grunt work. So let me show you what that would look like. So we're going to first begin by defining our function, but I want to define it using that x1 notation. That's going to be necessary for when we do our custom regression. We'll add a slider here, and for now, let's just pick a value for b. It's going to be not really going to matter. There's no restrictions on b, so let's just make b2. How about? So now we're going to write our expression here. We're going to say g of c plus 7, and then we're going to use that little squiggly to indicate we're doing a regression here. We want that to equal, through this regression, c over 4. Now, out comes this value of c, which we don't really care about directly. We only care about that value of c in that when that's essentially plugged into the choices, we want it to give us the value of B that we selected, right? This is the value of C that works given these parameters. And so if I need to see, in order to see which choice is right, I need to see which choice, when plugged in with this C, gives us our value of B back. So at this point, I can just try the choices out. So 15 over 4C, well, that's negative 25 and change. We're expecting 2. 19 over 4 times C, worse. So how about 61, how about 61C over 4 plus 105? Notice what I get. I get 2, which is what I picked for B. And notice if I went ahead and changed the value of B, look what happens to our value of choice C. It matches it, right? If it's negative 5.5, it's negative 5.5. If it's 6.7, it's 6.7. So this is a good sign that C works. And then if we just test, choice D, we see that it fails miserably. So best answer here is C.